Our next function is secant. So we have y equal to the secant of x, or we would normally just even say it, I'll take that off. We would really just abbreviate y is equal to the secant of x like this, okay? The key to graphing secant is that you, just like all of your normal graphing, you do 4 tick marks and label the last one 2 pi. Then you do 4 tick marks to the left and label the last one 2 pi. And you go up 1 and you go down 1. Remember that this is really pi over 2, pi, 3 pi over 2, and over here negative pi over 2, negative pi, and negative 3 pi over 2. Secant is a reciprocal of cosine, so to start with I like to just dash in the cosine function. Okay, if you remember the cosine function, if you do one complete cycle, it actually looks very much kind of like a tulip or something. Then if I do it on the left side, it looks just the same. So it looks like that. If you kept going, it's a periodic function and it just keeps going on and on and on. Like this. Okay, everywhere it crosses the x-axis, though, is going to give you a vertical asymptote. So everywhere cosine crosses the x-axis, it's going to give you a vertical asymptote for your secant function. So with the graph, everywhere, notice I'm just everywhere it crosses the x-axis, I'm putting in a vertical asymptote. So if I was, and when you actually graph it then, they share maximum points of 1 here, and it goes up. They look rather like parabolas, but they're not truly parabolic, they're asymptotic. But the pictures of them kind of remind you of little parabolas. And it goes up here. This would be right here, and it would come down here. Okay, if I were to describe where the asymptotes are, this would be like, I didn't label this, but this would be like negative 5 pi over 2. So I'd have negative 5 pi over 2, negative 3 pi over 2, negative 1 pi over 2, positive pi over 2, positive 3 pi over 2, positive 5 pi over 2, just kind of keeps going, okay? So if you were going to describe where these work, as somebody asked you, where are the vertical asymptotes? Where are the vertical asymptotes? We would say they occur at odd multiples of pi over 2. Okay? If you were going to be asked what is the domain of this function, the domain is going to be x such that x does not equal odd multiples of pi over 2. Sometimes your test generator will put in parentheses 90 degrees, since pi over 2 is 90 degrees. For the range, remember that's bottom to top, so the lowest it goes, it would be y such that it's going to go from negative infinity to negative 1 union 1 to infinity. Okay? So there would be describing it from negative infinity to 1. Then it really doesn't include the portion from negative 1 to 1, but then it starts again from 1 to infinity. It has a fundamental period of 2 pi. And that is our, fundamental period of 2 pi, and that is our secant function.